All right, this is Miss DH coming to you about Chapter 11, Lesson 3, Dividing Polynomials, Long Division. Now, if you hated long division in 3rd and 4th grade, let me tell you, you're not going to enjoy it much in 8th grade or whenever you're taking this class, because long division with polynomials it's not that hard, but it can get a little confusing, and you need to make sure you keep track of your pluses and minuses. Okay? All right, so let's go ahead and talk about first dividing a polynomial by a mononomial. This is the easy part. We're going to distribute the reciprocal. So here is the first problem. We're going to multiply by the reciprocal. Well, what's the reciprocal of 3m to the second? Well, it'd be 1 over 3m to the second. Then we're going to distribute that. Okay? So now we turned it into a multiplication problem, and we just need to distribute. So everything gets divided basically by 3m to the second. 3m to the third divided by 3m to the second minus 6m to the second over 3m to the second plus m over 3m to the second. So let's go ahead and do this division, canceling out what we have the same on the top and the bottom. So for this first term, 3's cancel out and 2 of the m's cancel out. All right. The second term, the 6 divided by 3 is 2, and the m to the second divided by m to the second just cancel each other out. And then m cancels out one of the m's on the bottom, leaving me with 1 over 3m. That's it. All right. And if you needed another one, here it is. We have the original problem, which is division, and we take the reciprocal of 4t to the second, and then we distribute. All right. And then we're going to cancel out some stuff. All right. The 4 and the 8 and the 4 simplifies to 2. The 3, then we're left with t to the third. The 16 and the 4 simplify to 4. The t to the third over t to the second simplifies to t. T to the 4t to the second over 4t to the second just simplifies to 1. So you need to keep the 1. And then we end up with 1 over 2t. All right. So if you needed to see that a little slower, or once again, there we go. Okay? There we go. That's it. All right? Now that was the easy stuff. That was definitely the easy stuff. Now let's talk about long division. When you have a polynomial multiplied by another polynomial. Well, you're just going to do long division. Okay? So, let's go ahead and do this. And at least if nothing else, there's no factoring right now, so be thankful about that. So let's go ahead and set it up the same way we'd do long division if we were dividing, like 5,274,015 by 12. Same difference, okay? So let's go ahead and set it up. There's my division house, and notice how I went through and added the opposite with everything. I recommend you do this. I personally had to do several of these problems twice because I got my pluses and minuses confused. All right, so don't be like Miss DH and don't get them confused. So now, just like regular division, we're going to break it up. I'm going to look at the first thing. What can I multiply by b plus 1 so that I can get rid of 2b to the second? Well, I need to multiply b by 2b to get b to be 2b. This is the multiplying part, all right? So I need to multiply b times 2b, but since b plus 1 doesn't go into 2b evenly, I have to put basically a placeholder because nothing goes directly into that because 0 times that is 0, right? This should be review from long division again from like 3rd grade. It's the same setup and the same idea. But I know that I can get b plus 1 into 2b squared plus negative b. So I can do that if I multiply it by 2b. All right? So then I'm going to distribute. So 2b times b is 2b to the second. 2b times 1 is 2b. Now we're going to subtract the same way you would do with regular long division. And I'm going to add the opposite to show it. All right? So if I add the opposite, I'm adding negative 2b squared plus negative 2b. Well, 2b squared plus negative b plus negative 2b plus negative 2b is 0 plus negative 3b. All right? Because this ends up canceling out, leaving me just this. Then, just like regular division, I'm going to drop the plus negative 3 down. All right? Well, what goes into negative 3b? Well, b does if I multiply it by negative 3, because again, I'm trying to get it so it cancels out. So I'm going to multiply this whole thing by negative 3. Negative 3 times b is negative 3b. Negative 3 times 1 is negative 3. Then, by adding the opposite, everything cancels out and I have no remainder, which leaves me with my final answer right there. Okay? So again, this is just like crazy old regular long division. It's just you got letters and exponents now. All right? So let's go ahead and look at the next problem. So we have 6m to the second minus 5m minus 7 divided by 2m plus 1. And notice how the first number always, or the first polynomial goes inside of the fraction bar, inside of the division house, and the second polynomial goes outside of the division house, right? Okay, so then I went through and added the opposites. That's where the plus negative 5 and plus negative 5m and plus negative 7 comes from, all right? So now I need to think, does 2m plus 1 go into 6m to the second? No, but does 2m plus 1 go into 6m to the second plus negative 5m? Why, yes, it does, if I multiply 2m plus 1 times 3. So I'm going to multiply it by 3m. So therefore, that went way too fast. All right, so I'll talk about what just happened there. So 3m times 2m gives me 6m squared. 3m times 1 gives me 3m. But I'm going to subtract these because just like regular long division, you have to subtract to get rid of them. So by subtracting, I then add the opposite. So now it's plus negative 6m to the second plus negative 3m. All right, so if we do that again, so I multiply, add the opposite, and there we go. So 6m to the second plus negative 6m to the second is 0. Negative 5m plus negative 3m is negative 8m, and I drop down the negative 7. Now, 2m plus 1 goes into negative 8m minus 7 if I multiply by negative 4. Then I'm going to multiply. All right, so then I ended up with negative 8m plus negative 4, but then I added the opposite, and I'm going to get plus positive 8m plus positive 4. Now, negative 8m plus 8m is 0, and negative 7 plus 4 is negative 3. Now, there's no way that I can get 2m plus 1 into negative 3. Nothing works. So therefore, I have a remainder, which I can write as a fraction, where I have the remainder over the divisor. And the divisor is the thing outside of the house, also known as the second polynomial. So I'm going to write my fraction as negative 3 over 3m plus 1. So there we go. That's the final answer. All right? So whenever you have a remainder, you're going to have that scary fraction at the end. Okay? All right, let's move on. If a term is missing, add a power with a coefficient of 0. So as you can see, if I were to write this in standard form, I'm missing an exponent of 3, t to the third. But since I'm kind of adding it in there, I'm really going to be adding like a 0. So just add a 0. So again, the first polynomial goes inside the house, and the second polynomial goes outside of the house. And notice how I added that 0, t to the third. All right? So again, we're just going to go ahead and do long division. How can I get t into t to the fourth? Well, I'd need to multiply it by t to the third. There we go. Add the opposite, and I'm left with 1 t to the third. Drop down my t to the second. Well, to get t to go into t to the third, I need to multiply by t to the second. T to the second times t is 1 t to the third. T to the second times negative 1 is negative t to the second. Add the opposite, and I'm left with 2t to the second. Drop down a t. Well, I can get that in there by, oh, it's going so fast. Okay, so there's no remainder. All right, sorry about that, guys. That's going so fast. But definitely go through and check what I've done here. Basically, it's what we did in the last problem, just remembering to add if we are missing any powers of a number between my highest power and my lowest power. Okay, so here's another example. c to the third minus 4c plus 12. And missing is 0t to the second. Added the opposite. All right, so how do I get c into c to the third? Well, I got to multiply by c to the second. Add the opposite, and I'm left with negative 3c to the second plus negative 4c. All right, well, to do that, I'd need to multiply by negative 3c to get that to work out. And again, guys, you're just distributing. Everything gets distributed. All right, you need to pay attention to that. That's how I'm getting this to cancel out. All right, add the opposite, and I'm going to end up with 5c plus 12. So if I multiply by 5, I'm left with negative 3. Since negative 3 is a remainder, I have to write it as a remainder with a fraction. There we go. All right, now don't forget to reorder polynomials into standard form before dividing. And remember, you start with your biggest exponent and get down to your smallest. So I'm going to reorder. Notice how we have 8x to the second plus 10x plus negative 1. That's in standard form. And I also needed to put my divisor polynomial, 1 plus 2x. Well, that needs to go into standard form. So that would be 2x plus 1. So let's go ahead and make my division house and divide the way we've been dividing on all the rest of the problems. All right. So there we go. There we go. There we go. And we do have a remainder of negative 4. So it's negative 4 over 2x plus 1. All right, I don't think I have any other problems other than the basic steps to remember. So you're going to divide, then you're going to multiply, then you're going to subtract, then bring down, and then repeat as necessary. And just remember that if you end up with a remainder, it needs to become that funky fraction with the quotient plus the remainder over divisor. All right, guys, I'm done. Good luck with this. I hate long division. Bye.